Here in this presentation, we will discuss different types of data structures. So let's get started. Here we have two types of data structures. One are linear data structures and the other one are non-linear data structures. So let's discuss them one by one. A data structure is linear when all the elements are arranged in a linear or sequential order. If the elements are arranged in a linear order or sequential order, then we can say that a data structure is a linear data structure. For example, we have arrays, queues, linked lists, and stacks. These data structures are all linear data structures. There is one more way we can say that a particular data structure is a linear data structure. When each element of the data structure has only one predecessor and one successor, then we can say that that data structure is a linear data structure. We can see in this example that each element is having only one predecessor and one successor. Here you can see this element has only one predecessor and one successor, right? Although there is one exception also. The first element and the last elements, you can see clearly, first element has no predecessor and last element has no successor. So this is an exception, although each and every element of the data structure has this property. That is, each element has one predecessor and one successor. Now, let's discuss non-linear data structures. A data structure is non-linear when all the elements are not arranged in a linear or sequential order. There is no linear arrangement of the elements. For example, here we can take this data structure. This is a tree data structure as I have labeled over here. This data structure is not linear. Why we are saying that this data structure is non-linear? You can see here that each node does not have one predecessor and one successor. You can see here this node has one predecessor, but it doesn't have one successor. It has two successors, right? So it is clear from this fact that this data structure is not a linear data structure. We have another example, that is graph. Graph is also a non-linear data structure. After understanding the difference between a linear data structure and a non-linear data structure, let's even go further. Even further distinction we can make. We do have static data structures and dynamic data structures. Let's discuss them one by one. In these type of data structures, the memory is allocated at compile time. So static data structures are those data structures where the memory is allocated at compile time. Therefore, maximum size is fixed. The advantage of such data structure is that we can access data very fast. But on the other hand, disadvantage is that slower insertion and deletion operations are there. We can take an example like this. Array data structure is a static data structure. Here you can see that we have to fix the size beforehand. That is why we are fixing the size at compilation time. That is when we are creating the code. Maximum size is always fixed in the case of arrays. Advantage is obviously that we can access the elements very fast, but slower insertion and deletion. We will discuss this why this disadvantage is there and why this advantage is there later. Right now you should understand this point that with static data structures we have this advantage and this disadvantage. Now let's see what are dynamic data structures. In these type of data structures, the memory is allocated at runtime. Therefore, maximum size is flexible. When the memory will be allocated at runtime, then user will decide the size. In that case, the size is flexible. Okay. Advantage is of course faster insertion and deletion, but again the disadvantage is slower access. So you can clearly see that there is nothing like that one data structure is better than the other. The advantage of one is the disadvantage of the other. So choice of data structures purely depends upon the user requirement. According to that, the data structure will get selected. So there is nothing like that one data structure is better than the other. Okay. And let me give you the example of a dynamic data structure. Here you can see the linked list is the best example of a dynamic data structure. We will discuss this later, that how linked lists can be created, what are the advantages and disadvantages. We'll discuss all these in subsequent lectures. Okay friends, this is it for now. Thank you for watching this presentation.